This video is the Unit 2 Section 4 quiz on chemical bonding. So why do atoms bond? Well, atoms bond because they want a full outer shell, or also called the valence shell, of electrons. For instance, take this atom in the bottom right. Notice that it has a half full outer shell. It only has 4 electrons, but it can fit 8. It really has two options here. It can either lose its outer shell entirely, having that full inner shell, or it can gain 4 more electrons and somehow have a full outer shell of 8. Atoms can do this by either sharing electrons or exchanging electrons with another atom, and we'll get into that a little more later. So we have two types of bonds. The first are called ionic bonds. These occur when atoms exchange their electrons, or in other words, one atom will gain electrons while the other atom loses. And these occur between a metal element and a non-metal element. In contrast, covalent bonds are when atoms share their outer electrons, their valence electrons, and these occur between 2 or more non-metal elements. Now, the skill for this part of the quiz is really focused on these last two rules. We'll differentiate between ionic bonds, looking at metal and non-metal elements, and covalent bonds when we have 2 or more non-metal elements. Let's take a look at the periodic table. We used this periodic table in class. We colored it a little bit differently. We got rid of these yellow metalloids. And we basically said that everything to the right of this staircase in blue is a non-metal element. Hydrogen being the one exception. It's a non-metal, but it's on the very left top corner. And everything to the left of the staircase, other than hydrogen, in red here, are our metal elements. Just as a reminder, ionic bonds are when we mix a metal and a non-metal element, and covalent bonds are when we have 2 or more non-metal elements bonded together. All right, let's do a quick check for your first question. What type of chemical bond is present between carbon and nitrogen with the symbols C and N? Go ahead and answer the question in the EdPuzzle. What you should have seen is that carbon and nitrogen are both blue. They're both nonmetals, and therefore this forms a covalent bond. For our second question, same kind of thing. What kind of chemical bond is present between MO, or molybdenum, and S, or sulfur? What you should have found is that molybdenum is a metal. It's in red right here in the center, and sulfur is in blue here on the right side. Because we have a mix of one metal and one nonmetal, we have an ionic bond. Now for our last question, let's talk about hydrogen, or H, and lithium, Li. What kind of bond is present between hydrogen H and lithium Li? What you'll find is both of these elements are in the top left corner. Hydrogen is a nonmetal and lithium is a metal. Because we have that mix of two elements, one metal, one nonmetal, we have an ionic bond. Now that we can differentiate between ionic bonds and covalent bonds, let's dive a little bit deeper into each type. Covalent bonds occur, like we said, when atoms share electrons. Here's an image of that happening. You can see A and B, these two elements, are sharing their valence electrons. So now they both have full outer shells, and they share these electrons right in the center. Now, covalent molecules, when we have these covalent bonds, can form giant structures where a ton of elements are connected all together. So the skill we're going to practice here is how to name these giant molecules. Now, how do we name them? Well, because covalently bonded molecules can have many atoms, we have to have a few different rules. The first rule is pretty simple. The second element in any covalent compound is going to change the ending of its word to "ide," or the ending of its name to IDE. We'll see what this looks like on the next slide. Our second rule is that we use prefixes to show the amount of every element. We want to use these prefixes to show how many of each element there are. And we can see this chart here on the right side that shows us the number and its corresponding prefix. For instance, the number 7, if we have 7 out of an atom, it should have the prefix hepta. Now we do have one exception to the rule. Every single element will get a prefix except when there is one of the first element. The first element will never get that one or mono prefix. We'll see this on the next slide. A few examples with our rules displayed here on the left, along with our prefix chart. Take a look at C2H6. If I take a step back, I can see this is 2 carbon atoms and 6 hydrogen atoms. So we need to put the prefix for 2 in front of carbon. We get dicarbon. And the prefix for 6 in front of hydrogen. So hexahydrid. But instead of hydrogen, we need to change that ending to IDE. So instead of hexahydrogen, we have hexahydride. Another example would be SH. We have 1 sulfur and 1 hydrogen. Remember that no number next to our element means 1. Now, because we have 1 of the first element, it doesn't get a mono. It doesn't get that prefix for 1. It's just sulfur. But the second element does get the mono prefix. Because there's 1 hydrogen, it's monohydride. Remember, we changed that ending to IDE. And we can do this skill in reverse. Diphosphorus decaoxide. Check out your chart. Di corresponds to 2, and deca corresponds to 10. So diphosphorus is 2 phosphorus atoms. Decaoxide is 10 oxygen atoms. And let's make our formula based on that. P2O10, 2 phosphorus, 10 oxygen. Now it's your turn. What is the name of the covalent molecule with the following formula, C4H10? Go ahead and respond on the EdPuzzle. What you should have found is that we have 4 carbons and 10 hydrogens. Therefore, we are tetracarbon, tetra being 4, and decahydride, deca being 10, and we change that element to IDE. What about this molecule? What is the name of this molecule? SF6. Go ahead and answer on the EdPuzzle. We have 1 sulfur and 6 fluorines. Because we don't use mono for the first element, it's just sulfur, not monosulfur. So just sulfur, and hexafluoride for the 6 fluorines. And let's do one backwards. What is the formula of the molecule carbon tetrabromide? If you bring this back to counting atoms, because there's no prefix on the first atom, it should be 1, because we don't use mono here. So if there's no prefix, it's 1. 1 carbon, and tetrabromide is for bromines. Therefore, our formula should be CBr4. There's no 1 there for the C because we don't write 1s. All right, last, let's talk about ionic bonds. Ionic bonds occur when atoms exchange electrons. And we can see that happening here. Atom A is giving its electron to B. So A lost an electron and B gained an electron. Now, ionic bonds, they can form large molecules, but really what we're concerned about is having equal numbers of positives and negatives. And we'll see how that looks in just a slide. And this is how we construct ionic formulas. The main rule is that in ionic formulas, the charges must add up to 0. In other words, there need to be equal amounts of positives and negative charges. For instance, if I have sodium, Na, with a +1 charge, and oxygen with a -2 charge, right now I have more negatives, so let me add another sodium atom. Now if I look at all my charges, I have a total positive value of +2, there are 2 +1s, and a total negative of -2 for my 1 oxygen atom. My formula then would be Na2 for my 2 sodium atoms, and O for my 1 oxygen atom. Remember, we didn't write the 1 here, we don't write 1s. Now, there is a quick trick that you can use to do this. The quickest way is to take your charges and switch the charges for the amounts of each ion. For instance, if Ca has a +2 charge, we'll put a 2 next to the P, and if P has a -3 charge, we'll put the 3 next to the Ca. Now, why does this work? Well, if I take a quick look, if I put 3 calcium ions here and 2 phosphorus ions here, notice that my total positive is +6, 2 + 2 + 2, and my total negative is -6, 3 and 3. Because we have an equal positive and negative, +6 and -6, this formula works. However, there was one exception to the quick trick. This quick trick does not work when the numbers are the same or they can be simplified or divided by the same number. For instance, magnesium and oxygen, both here have a +2 or a +2 and a -2 charge. If I do the quick trick and switch the charges, I should get Mg2O2. That is not the case though. I really only actually need 1 of each. And the reason should be obvious if we use our first way of calculating this. Mg2 plus, O2 minus. these automatically balance each other out with one of each atom. Now, luckily for us, ionic compounds are easy to name. First rule, the positive ion comes first, and the negative ion comes second. Next, the second element will change its ending to "ide" or IDE, just like we saw with covalent compounds. And finally, we don't need prefixes with ionic compounds. So if I take my first example, NaCl, we'll see that Na is +1, Cl is -1. Whichever method you use, you should end up with this formula, NaCl. Because there's sodium and chlorine, one of each, it's just going to be sodium chloride. That second element changed its ending to IDE. Notice that I don't need prefixes. I don't need to say there's one of each. With calcium and phosphorus, we get the formula Ca3P2. We have calcium and phosphorus. We don't need to count numbers because this is just ionic compounds. And so our compound would be called calcium phosphide. No prefixes needed. We just needed to change the ending of the second element. All right, now it's your turn. What is the formula for the following ionic compound? We have Be2 plus and F1 minus. Go ahead and answer on the EdPuzzle. For this, we should have gotten BeF2. You could use the switch trick or counting the number of atoms. So what is the name of this compound, this BeF2? Go ahead and answer on your EdPuzzle. The name of that is beryllium fluoride. Be is beryllium, and fluorine, the F, changes to fluoride. All right, let's do one more. What is the formula for this ionic compound? Sc3 plus, N3 minus. This should just be SCN. We only need one of each for it to balance. And what is the name of this ionic compound? What you should have found is that this is scandium nitride. Sc is scandium, and N for nitrogen changes to nitride. And that is it for the Unit 2, Section 4 quiz.